the idea, so why I do this and how I came interested in this Pyglet or games things, is because I do experiments and I program the experiments as a game when we run the experiments in people. I learned this Pyglet modules and Pygame because of that, and I figured that one is a very nice way of showing how you can do graphics in Python. Python, as you know, it's a very robust language and it's very heavy. So for gaming, it's in a way not the best platform to do it because it's too heavy. But still, you can do simple stuff with it, and even you can do 3D stuff with Python. And as probably maybe if you are in game development, you know that all the games, like the proper games, are done in engines. Game engines are in the end it runs in C. So Python is not in a way the best option, but it's nice because you can learn object-oriented programming with Python. So that's why I call the tutorials the tutorial lenses, because doing this game, we will do a very simple game, and then you will start to implement object-oriented programming concepts that maybe you will not be familiar with. So this is the first thing that I want to ask you. How many of you know to write classes and what a class means in Python? Okay, almost all of you. Very nice, okay. Okay, but it's not that difficult in Python as with C++ or something. So what we're going to do today, I will show you the end result first. Is this, which is game, the file game. It's this guy that is here, and some aliens are going down, and I have to shoot. So with one click, I shoot. And if I touch an invader, an alien, I die. That's it. That's what we're going to do. And I'll run it again. And I have a score there, up there. When I click, then the number of killed, the number of killed aliens goes up. And that's it. You know, it's not the most sophisticated game that you can have, right? But it's a start. So to learn how to program this, because you have to program your ship, the pallet, the aliens coming down, and so on. Do you find it interesting? So what you have in your files that I distributed in the repository, I will show you the folder. There are two folders, code and slides. The slides are the PDF that I'm showing, and in code there is this different Python files. First, I want to make sure that everybody is working with Python and with Pyglet. So I did this file that is called test Pyglet. You know, if you see it in the root, in the root folder of the root of that folder, and it just has this. And if you run it, it should give you that hello world. This hello world example is just to test that Pyglet works. And as you see, it's very simple. If you see the code, what is needed to write this actually is very simple. And I will try to explain first what is happening here, and then we will start with the proper game. So what Pyglet and Pygame also needs first is a window. So this piece of code, what it is that first is a window, then creates, so this line creates a window. So the window variable, it's an instantiation of the window object from Pyglet. So this is the window that is going to be shown. What it does now here is creating a label object, that is any kind of text that you want to write. And here you pass the text, the actual text, and then you can pass any other parameters like the height, position, X and Y on the screen, and where is it. So this label object contains the text, the object that will be presented. And what it needs also, always Pyglet and Pyglet, is a draw command, or a draw definition function. And what is draw is the function that will be called every time you want to draw on the screen. So this is also an important concept. When you have a game or when you have some graphics, you want to draw at, let's say, 30 hertz or 30 frames per second, which are or 60 frames per second, which are the framing interval from the screen. So you need this onDraw function always, and inside it will be the commands that are going to be called every time you draw. So this, what it does is that it clears, so everything is black. It clears the color buffer and everything, so it clears the window, so it's black, and then it draws this object. So this label object, as is defined in Pyglet, has a method that is called draw. So every time you draw this is going to be presented on the screen. So you define this in Python, and up to here nothing is happening. You're just defining, and here's when it runs. So Pyglet, what it does is that it collects first all the objects or things that you want to, that's belonging to the program, and then at the end you run it. I see some confused faces.
No. Okay, let's say that you want to present hello world for 2 seconds, and then you want to present something else.
Yeah, so this. This is something.
The size of the window is somewhere very
Here you can pass it. You can pass it. This is the default, but you can pass it here. Hello. Yes, so this is, as you will see here, this is the very, very simple example that doesn't have timing or anything. It's just doing all the time the same. So I will go now to the skeleton of the game. So if you open game 1, so this is the file that we're starting to work on. Game 1, there is a skeleton. There's a skeleton code for the game, and let's have a look together. So this I wrote. First, I am importing necessary things that you could use. So the random, the math module, and I import Pyglet. Just for simplicity, I'm importing from inside Pyglet. You have this window, clock, font, submodules. So what I'm going to show you also is that in the documentation, in the programming guide, you have API reference. So here, as you know, like with all modules in Python, you have the whole documentation online. And you see that here in Pyglet you have app, clock, event, font, and so on. Image. So all this we're going to use, but they're very well documented. So it's a bit intuitive what they do. So this is the imports that we need for this time. Then what we do is that we have one class that is called Space Game, which is a subclass of window. So it's a subclass of Pyglet window. If you go here, Pyglet window has a class that is called window. So this class has different events, have different methods, so everything is there and have different properties and attributes. For example, the class window already has point width, point height, so it already has these things. Okay, so yeah, let's leave it there for a moment. So this class has different methods, blah blah blah. Then I have a class Spaceship, that is the one we're going to be using. And then, if you see on the bottom, then here, if I call this file as a main, then what it does is creates a Spice game object with some caption, height, width, and this then it's run. So what I do is that I define my classes up there, and here I run the game. If you run this, if you run game 1, it should be a black screen of 800 times 600, and it will just have a text here down as FPS something. And you see that the window has this caption also, which is given here. Do you have that? Do you have that?
Yes.
Yes? Okay, so now let's go into what is actually going on here. What is happening is that here you're calling a space game, right? You're creating a window that is called space game. So it's an instance of space game. And a space game has these methods. An initialization method is in it. It has this onDraw method. That is the method that is called every time that you want to draw, that the system wants to draw. It has this update, which now is not doing anything. And it has, I put this event handlers. This is all standard in Pyglet or Pygame. And what happens is that when the system recognizes that you move the mouse, or you press a key, or you press a click in the mouse, then these functions are called automatically. So Pyglet, when Pyglet runs this object space game, if the object has these functions, it will be automatically recognized and will be called every time that you press a key, you move the mouse, you drag the mouse, you press the mouse. Right? And init is the function that is called at the beginning when you create the object. Right? So this is, in a way, for the ones that don't know, this is the object-oriented part. You have a class that you put the name. It can or cannot be subclass of another class. In this case, I'm creating this as a window. So this is a subclass of something that is already existing in Pyglet. And what it does, this class, is that when it's initiated, this is executed, and then you can call these functions separately. And so let's see what is happening here. In the initialization function, what is happening is that all the arguments that I'm passing to the space game class are simply passed to the window initialization routine. And I'm saving this in Win. And this is the other key thing to objects, is that you save your variables, you have to save it inside self. So self is always passed as an argument, and is what is storing all the variables and all the definitions of the class. So I'm saving the window there, here I'm just, this is not important for the moment, and then here I'm creating the text, the frames per second text, which is going to be down left. And in the onDraw, which is called every time you draw, what it's doing is that it's clearing the window, taking the clock, setting the text, drawing the text, and flipping. Flipping is for the graphic card to what you draw in the graphic card to actually present it. So usually when you draw, when games are more, or when graphics are more extensive, you can draw a lot of things in the graphics buffer, and then you want that they appear simultaneously. So for that, you use double buffer, and then you flip the buffer. And this command is actually when it happens. When this command is executed, everything is presented. This is a detail, and it's not very important. Do you have any question up to here? You clock the tick, so this tick ticks the clock, which means that the clock that is part of Pyglet advances one step more. That's it. It's just to have the track of time.
If you don't tick it?
If you don't tick it, then it will be, so I think, I'm not sure, but I think that the clock will be stopped. So the frames per second, for example, the information that you get from the frames per second function, it will always be the same. Do you understand this division between drawing, creation of object, and drawing? Do you have any question?
I still have a question about flipping, because I was doing some experiments with this, and I created another text object which should appear on key press, which it does, but it disappears immediately. So why does this happen?
So imagine that. So this is the screen.
Yes.
And this is connected to the graphics card. And these graphic cards usually have two buffers, which is called the front and the back buffer. Front and the back buffer. This is OpenGL stuff, but this is important to know. So what is presented on the screen is always the front buffer. So the things that are written here, so imagine that the screen, when it has the screen, is also here as a representation in pixels. So, and your program, your CPU, and your program is here. And when your program is running, what you're doing is that you're drawing with the command draw of any object. You're drawing to the back buffer.
Yes.
And you draw, at every cycle, you draw all your stuff in the back buffer. And when you finish drawing, what you do is that you flip this.
No, this is what I get. This is perfectly clear.
Okay.
I should do a flip, but it disappears immediately.
Did you put it in the on?
I put it on key press.
On key press.
Yeah, and then it disappears automatically.
Because then afterwards the key is not pressed.
Okay, so it's okay. But I thought I drew it, and then it stays on the screen. Why does it stay?
No, because every time you're clearing the buffer at every cycle.
Okay, the on-draw happens every cycle.
Yeah. So this on-draw, the on-draw, which is this process, is drawn at 30 hertz, let's say.
Okay.
So every time you want, you have to draw. Every time it's drawing something new.
Yes, I see.
Yeah.
Okay.
And this, for the rest, that's why we need the flip, because we need to flip this with this.
Okay.
So this every time is flipped, then the next cycle you write everything, then you flip again, and so on. This is how it works.
It's not that much to do if you want to keep the same thing. If you want to keep the same thing,
you have to draw everything again. That's why, this is how graphic cards work, actually. This is, I think, the choosing of this thing is because you may have a program that takes a long time to draw. So you don't want that when you're drawing on the screen, when you're presenting on the screen, that some things appear before than others. Right? So this is called double buffering. And you will see that in NVIDIA, for example, in your settings of your NVIDIA card, you can choose this or not choose this. You can also use single buffering, which is just one. And if it's a light program, it will be exactly the same. So this is with the flipping, if you have questions. But the important thing here is that you have this onDraw method that is executed every time, every 30 at 30 Hertz. And what it's doing is that it's clearing the screen, it's drawing the text that is up down, and then it's presenting everything at the same time. And what is this FPS text? This FPS text is up here. It's here, and it's instantiation of font.txt. Font is a Pyglet submodule, and what it's doing is that this text is saved here, and this is saved at the beginning of when you create the game. So you don't create the text object every time that you draw. You just create it, you save it, and every time you draw, you only draw. Otherwise, it will take a long time. So this thing just opens a window and presents this text here, and that's it. So the idea now is that we're going to load the different images, the spaceship, the invaders, and we will start to draw them inside. Any questions to share? Okay, so we will first load the spaceship. We will create the spaceship. Inside the folders, you will see that in the folder images, I have a spaceship, 2 files actually, spaceship 2 and ship 3, which are just bitmaps, are just images. So what we will do is that I will show you how to load them. For that, you will use the image module. So Pyglet already has a submodule that is called image, and you just load the file image. So it's images, I think it is images chip.
Do you mind if I close the window? It's getting quite cold.
Okay. So you can also check in the documentation if you have image. The submodule image has this function that is called load, and you just pass the file and it will load the image. So it will automatically recognize the format and it will load it as a bitmap. So this I will save in spaceship image, let's say. And this I will do it at the beginning of the code, so at the beginning of the game, in the init function. Is it too small or not? So I'm loading the image, and I'm saving it inside the object, in the self, as a spaceship image. Yeah? And now I want to create, what I will do is that I will create, I will use my class that I have down that is called Spaceship. So I will write it first and I will explain you what it does. Spaceship, spaceship image, and this will be called spaceship. So here is the image. So it's in a way the bitmap, the variable that contains the bitmap. And this spaceship image, bitmap, I'm passing it as an argument for the class spaceship. So I'm doing an instance of the class spaceship, which is at the bottom of the code. You see it here? The spaceship class, I haven't talked about it yet. The spaceship class will have all the things that concerns the spaceship. So it's an object. Imagine that it's a spaceship object, and we will write more things here. But the spaceship is a subclass, or is an example of a sprite. And what is a sprite? It's something very useful that Pyglet has. A sprite is just an object that will be drawn on the screen. So it has width, height, x, y position, attributes, draw attributes, and so on. So this is done already. So I will here. If you do the documentation, the sprite is difficult to explain what is a sprite, but a sprite is in a way is an element that it will be drawn on the screen. So if you create a sprite object, we'll have draw method, it will have x and y position, you have the position, you could rotate and scale them if you want, you have the width and the height, and so on. So this is a sprite. So this is what I'm doing here is that if you see the class definition, I'm just passing the arguments of the spaceship to the sprite initialization. So actually, this is just wrapping a sprite. Here we can add other stuff afterwards, but this is just creating a sprite. So this, if you go up now in the initialization, the spaceship variable will be an instance of spaceship class. Yeah? And so this is, if you run it like this, nothing will happen. So it will load the file, it will be saved in spaceship, but it will not be drawn. So what you need is added in the onDraw method. So here you say self spaceship, which is my object, draw. And this will be drawn on the 0, 0 coordinate. So this is another thing that is important. 0, 0 is the bottom left. And so the coordinates is inverted. So this x, the y coordinates is inverted. This x is to the right is positive, but y to the up is positive. So here is 0, 0. Do you have this?
It's 0, 0, then the axes are correct. It's 0, 0. So the x increase to the right?
Yeah, so yeah, you're right. Yeah, it's not inverted, sorry. It's not
it's inverted in screen, because screen,
yes. So if you want to imagine that you want to draw in another place, you can just say in the onDraw, or before when you define it, you can just say self spaceship x is, I don't know, self width divided by 2, and self spaceship y self width height divided by 2. Sorry. Now let's say 100 and 400. Yeah.
Why does it work when you put
When
some?
you put win, I don't know.
Because for me, I get some error. I don't know what you got.
I thought you could do it like this.
Yeah, you make it's not possible with floating numbers or doubles, so...
No, it has no attributes. No technically has no attributes.
Yeah, for me it said that as well.
We should work, actually.
But is it because you saved to the self.win the window.window.init?
No, this is the...
Yeah, but this one...
no, it's self-width, yeah, exactly.
Yeah, if you
Ah.
get the little bit of almost the one.
So it's self, height, divided by 2. So if you want to draw it in a different place, then you just change, as you see here, you change the x and y attributes of the spaceship object. So I just, again, I created the spaceship sprite, and in the onDraw method, I put x and y as the middle of the screen, and then I draw it. So the idea now, step 3, we are in step 3, is to move the spaceship, so to make it a bit more interactive. So how can you do that? And the idea here now will be that the user, when he moves the mouse, it will change the position of the spaceship. So how can we do that? We can use the on-mouse motion method that already exists. So what it does, this method is called every time that a mouse motion is detected. And it has x, y, already x and y of the mouse position of the mouse. The x and the y has the change, so you could eventually calculate the velocity. So what I said, make a spaceship location change according to the mouse position. And for that, use the event handler on mouse motion. So what you have to do, now I will erase this here in the onDraw position, so because I don't want it here. What I want is that the x and y position of the spaceship will be determined when I move the mouse. And this is simply x and y. The x and the y is the change. So I just put in the onDraw, I just have the draw of the spaceship, nothing else. And in the on mouse motion method, I'm assigning the x and y position of the spaceship as the x and y of the mouse. And if you run it, then the ship follows you. It follows you because you're assigning x and y of the mouse to the x and y of the spaceship, right? What I would like though is that when I move the mouse, no matter what, the spaceship only moves on the horizontal axis, let's say. So it stays at one position, here down. So it only does this. So how can you do that? You just wanted to move it in this direction, the horizontal direction. You don't assign y. So you don't do that, but you just say the spaceship y position is always 50, let's say. So then it will be like this. So with the mouse you will move it left and right, but it will fix at 50. And instead of doing it here in the on mouse motion, you can just do it here when you're calling the spaceship. So you're assigning when you're assigning the spaceship object, you just say y equals 50 because it accepts x and y arguments, the sprite actually, and here you don't need it to do it here. So now you have this. Okay, so now, fourth step. The fourth step is now we want to add other components, so the aliens. So we will do more or less exactly the same. So we will create an alien object that will load the image. One of these images that are here, in maybe this one, the invader.png, and we will make them move down. So they have to fall to the spaceship. So let's start. We can start loading the image. So we do exactly the same as the spaceship, but now with the alien image. So Pyglet image load, and then it was Invader. Invaders.png. So this is now saved in the alien image. And now, what my instruction says is that it's good that we create another class, because they will behave differently afterwards. We can create another class that is called alien. But for the moment, it will be exactly the same. It will be a sprite. But we will see that this will change. So we create another class, we copy and paste the spaceship definition, and then we create an alien definition. And now, similarly, here you can create one alien, self-alien, and this will be an alien instantiation of self-alien image. And there I could immediately say here X is, say, 400, Y is 500. And in the draw, I have to draw it. So I call alien draw. So I added this here. So I call the alien image, and I load the image, and I call an alien instance, and I'm giving it immediately the position. This will change. It is ready for draw. I'm drawing the alien, and downstairs here I just add a new alien, which is a copy of the spaceship. And if you run it, you have one alien there, right? You cannot show it, of course, because it's not. Let's move the alien now, because it has to go down, right? So for that, you can now we will use the update method. So what do we need? We need that the alien starts somewhere up, and then when time passes, the position goes down, right? So. How can we do this? Because here I'm calling the alien with a specific position, right? So we need the alien to go. We need that. If this is the game, it will start here and it will go down. So which one should be the initial position? The initial position should be somewhere here, right? We can draw it randomly. In the X and in the Y should be the screen height, the window height, right? So we can call first when we call the alien, we can call it as with a Y position of self height, which is the height of the window, right? It's an attribute of this space game class. And in X, we can do it randomly on the width. So for that, we can use rand int between 0 and self width. Let's say like this. So we will call the alien, the position will be in the x will be random between zero and the window width, and the position on the y will be the height. So it will be up. And now we need the alien to go up. So we need to update the position of the alien every time passes. For that, we need to create some things in my alien object. For a start, we need to create, let's create first the update method. The update method will be called every time you update the objects. What it means here. So every time it's drawn. And what I want is that the position in the y-axis decreases. Decreases because it's already the height, let's say 100. And it will go to 0, right? So what I need is that it decreases by a certain amount. And this amount at every time step will be the velocity. So can say y velocity, and the velocity can be fixed, right? So I can determine the velocity every time I call the alien. When I create an alien, I will say the y velocity is 5, and every time you update, the position on the y will be decreased by an amount of 5 in this case. Yeah? So the position is, I'm just on the y-axis. And I need to call this update, right? Every time. So this you added in the update of the window. So here it will be every time you update, it will be self alien update. So update is called, you will see here that it's called every 30 charts. So every time the alien is updated, so it's the update function is called, and what is happening? What is happening is that the y is decreasing every time by 5. And when you do that, this is what happens, right? Now the position is randomly, as we chose the x position to be random. Now every time I run it, it's a random position on the x-axis. Right? So this I'm determining the velocity in a way a step that I will decrease every time. And here in the update method, I'm saying y, attribute y is decreased by this amount every time. And the update is called up every time you update. Yeah? So you see, this is very object-oriented programming in a way that you have to change things here. You can create different functions here that are called here and so on. So now we need, step 5. We need more aliens, right? Here we just have one. And maybe you can imagine that you could create more of this, right? More of these aliens at the beginning and just start to draw out. Right? So this is something that we could do. But another way of doing it is that every some seconds, after some time interval, call a function that will create new aliens, or one new alien, let's say. So this is what is called here. We could create a new function. I think this is the best way of doing it. So I will create a new function that is called create alien. And this function is part of the game, part of a space game. And what is this function going to do? This function is going to create a new alien. And I will tell Pyglet, call this function every some seconds, every some milliseconds. So what I will do is that I will not put this here. The calling of the aliens will not be up here, but it will be inside this create alien, and I will make a list. So when I start a program, I will create a list of aliens, which is empty. And every time create alien is called, I will append to the list one instance of alien. Let me do it like this. So when the program starts, this is empty, the list is empty, and when this function is called, you will append one alien called like this. So randomly on the x-axis and always up. Yeah? Now we need other fixes for this to work, because we will start to create many aliens and then they have to also be removed, right? And this function has to be called every some seconds. And this is actually what you do here. This clock schedule interval is the function that tells Pyglet, call this function every that interval in seconds. So what we can do here is that we could create another line. So here you see that update, the function update, is called every at 30 Hz. So here we can create another scheduled interval, and here we will create an alien. Create alien. And let's do this less frequent. Let's say every 0.5 seconds. Right? So here we're calling create alien, the function, every 0.5 seconds. And this function, what it's doing is creating an alien and appending to this list. Now we need to draw them. So here in the drawing method, now I have to draw all the aliens that I have in the list. So I do for alien in self aliens, I draw them. So if you run it, here. I also need to update every alien. I forgot this. So for every alien, I also need to update them. So I have to also change it in the update method. For alien in self aliens, I update every alien. So I change this, I put a for loop here, a for loop in the drawing method, and that's it. Now it should work. The create alien needs all these functions that are called with this schedule interval. It needs a second argument, which is dt. There's a difference in time. I'm not using it, but it's expecting a second argument. And now it's working. So this create alien, has this dt. If you have an error of second argument. So there's one thing that we didn't do, that we need to do, is that to clear the aliens, because here I'm appending to a list and eventually it will grow and grow, right? So when the aliens arrive to the lower part, then they have to be removed, right? They're not needed anymore. So for that, we can do an easy way of doing it is to add an attribute to the alien that a variable called dead. And initially, the alien is not dead. So that is false. And in the update method, if the alien position in the y-axis is less than 0, right? Then it's dead. Yeah? And how I'm going to use this dead? I'm going to use it in the update of the game. So every time I update, I check if the alien is dead. If the alien is dead, then I remove them from the list. And for that I use the method remove of lists. So I define the dead here in the alien, and if this is true, if alien.dead, for every alien, if the alien is dead, then I remove the alien from the list aliens. Right? And I define the dead of an alien here down. Initially, the alien is not dead, that is false. But then in the update, if the position of the alien is less than 0, then the alien is dead. So again, I define a new variable that's dead, and the alien can be dead or not. Initially it's not dead, so it's false. And in the update, if the position in the y-axis is less than 0, so false below the screen, then it's true. And I'm going to use this attribute of the alien to, when I update them, when I update all the aliens here, if the alien is dead, then I will remove them from the list aliens. Okay, so this is just to keep track that they don't accumulate. Okay. Okay, and I will, to make it less boring, I will add some horizontal velocity, because they're just doing like this, right? In the y-axis. So what I could do is that I could also define an x velocity in the alien velocity, and the x velocity will be randomly between -3 and 3, whatever, every time, for every alien. And when it's updated, then I repeat exactly the same that for the x-axis. This is just to make it less boring, I would say. It's not, oops. So I added randomness in the x-axis, so it will be like this. Between these values, but it doesn't matter. And then in the update, I just also do it for the x position. So I do exactly the same, but now with the x velocity. This is just to add some variability, and then it will be like this, right? Actually, it's not one. This is fast. So the last thing is to create the bullet. The bullet that will be shoot. The spaceship will shoot, and then we will detect when the bullet and the invader collide, right? So we create the bullet exactly similarly as we create the chip and the invader. So we will do a sprite, and you can think that you could have many bullets, right, at the same time. So we will also do a list. So we will create exactly the same now. For instead of aliens, I will create a list of bullets. So first I will call the image. Pyglet image load, and I have two bullets there. One is smaller than the other one. So this is the 16 is the bigger one. So I will just load this image, Similarly, what we did before. So, valid image, and then I will create again a list, an empty list of valids in the init part. So this is just loading the image and creating an empty list, similar to what we have for the aliens. But now the aliens were created every some time, right? After some time passed, then a new alien was appended to the list. Now we have to do the same, but now every time you click, right? So this is done. So every time you click, this function on mouse press is executed. So here we need to add the append. So wait, before that, I will also create a new class that will be called valid. So let's copy the spaceship and let's create a new one called valid. So it inherits the methods of sprites. So I just copy the spaceship one and I call it valid now. And here we can see that we can also do an update method. So we have a valid. So every time you press the mouse, we append to the list valids a new object called valid, passing the image valid and with some coordinates. And these coordinates, what should be? So every time you press the mouse, I will append to the list of valids, I will append one instance of a valid, which is, it takes the image that I already saved, and I have to put a position, an initial position. So let's try X and Y for a start. Then we'll see that we have to change it. And so every time I press the mouse, I will create this valid instance that it will take this image and it will create at the mouse position actually. And I need the valid also to be updated. But now this is similar to the aliens. So I also need a velocity, but now the valid will go up, not down. So I will also define a y velocity of 5, and at every update I will update its y position, but now it will be sum. Do you get why? Because it has to go up. So it's the inverse of what the aliens are doing. The aliens are discounting, and here it's augmenting. So I have this class, valid. I create one valid every time I press click. And now I also need to draw them and to update. So it's exactly the same as with the aliens. So in the update, I need to, for every valid in valids, I update every valid, and for every valid in valids, I draw them. this is, because we're using this list, this is exactly the same as with the aliens. So I go through the list of bullets and I draw them I draw all of them, and for the update also, I update every bullet. Yeah, we're not done because no, it starts where your mouse is. So they need to start here. They need to start where the spaceship is, right? Because why happens this? Because in the on mouse press, I pass the X and Y of the on mouse press, which is the mouse position. So what I need is just to say spaceship X and spaceship Y. This also will not be optimal, but it will be better. So even if I have the mouse here up, then they originate from the spaceship. Now if you see, they originate from the lower corner, lower left corner. Because all the sprites, the anchor is always down left. That's why. So if you want to fix it easily, you can just add the width of the spaceship. The width, the half width. So divided by 2 and self spaceship height divided by 2. So you center the position. Sorry. So there. So now they're more or less originating in the tip, right? So as you see, adding more stuff, in a way you have to create your class if you want. If it's something different, you can. If it's something that behaves different, then you have to create a new class. In this case, the bullet is different than the alien because they move in different directions, right? You could also make just one class and assign the velocity. That's also possible, right? Velocities, positives and negatives, for example. I just decided to do it like this, is clearer. And also here, I forgot, also you need to kill the bullets. So when they go up, after the window finish, up, then you also need to remove them. So you also need to do exactly the same. So I will also create an attribute for the bullet which is called dead. So at the beginning is false, but then in every update, if self y is greater than the window height, and this is something that it may be interesting. We need the height of the window, and we need to pass it somehow to the bullet. So one possible thing to do, this is how I resolve it, is that when you call the bullet here, you also pass the height of the window. Self height, yes. So when you call the bullet, you also pass the height of the window. I will call it height. So it's called height in the space game, and then this is saved. This one is created. So then it has to be saved. I will call it top because I think it cannot be used. And here I have to call. So how did I do that? Top and here image. So let's see if this works. Yes. Okay. So what I did, this is maybe not the best way, but what I did is that I wanted to pass something to the bullet when I created. So when I create them here in every mouse press, I wanted to pass the height of the window because it can change depending on on the height of the window. And for that, I pass the arguments here now invalid explicitly. So the image and top, which is the height, and then I call the sprite with image and top, and just save it here. So now if the position in the Y is bigger than top, then that is true. So similarly, I have to do the same here for the balance. If valid dead is true, then I remove it from the list. So again, this if you want to pass to this class something that is explicit, I just put explicit arguments here. And this because I look it up in the Sprite documentation. So I know that the first argument, it has to be the bitmap of the image. And then I just pass this, the rest are just passed directly. And I save the height as a variable that is called top. That's it. I think you could do it in a different way. If you see, we are shooting bullets, we're shooting, the aliens are falling down, and the bullets are going up. So what is missing? So what is missing is that the detecting when the bullet collides with a monster. And if that happens, something happens. So they are removed from the window, let's say. They are removed from that killed. Right? So how can you do that? One way of doing it, so there's a whole thing of collision detection in games. What I will simply do is I will calculate the distance between bullets and objects. And if the distance is small enough, then I say they are colliding, so I will remove them. So for that, I will define a function, distance. Even outside the class, because this will be used, it's a global. So let's define a function distance, and this will return the Euclidean distance. So the square root of the x's summed and squared and summed by the y's summed and squared. This is why I needed the math. Actually, the math is important. You could also do it in a different way and not calculate the square root, because the square root is something heavy, computationally heavy. So you could also do it just with squares. And then the amount that you're comparing, also squaring it, and it would be exactly the same. But just for a matter of simplicity, let's say that we're calculating the actual distance in pixels. So why I'm passing this here, like a.x and b.x, is because I want to just pass the alien or the bullet or the spaceship as an object here. So I'm passing two objects. Imagine that this function is taking two objects, and these two objects have x and y attributes. So you cannot, with this function, you cannot do it. So you have to have an object that has .x and .y. So this I define it outside. You can define it in another file if you want distance. And now, what do we need? We need that in every update, so I update the aliens, I remove them if they are out of the screen. I update the palettes, and I remove them if they are out of the screen. And here in the update, I could say calculate the distance for every alien with every palette, and if the distance is close, then remove them or make them dead, let's say. So I would say the easiest or the clearest way would be, maybe not the most efficient way for sure, is to say for every alien in the list of aliens, and for every bullet in the list of bullets, yeah, calculate the distance between the alien and the bullet. This function distance will work because this and this are objects that have x and y positions. And if this distance is small enough, I don't know, 10. Let's just make a trial. If this is small enough, then I mark both as dead. So this part is checking collisions between aliens and bullets. So actually I'm not removing them here, I'm just marking them as dead. And in the next step, they will be removed here. Right? I could remove them off the list also. But let's make it clear like this. So now if we run it, oh, it doesn't work. Why don't we? Yeah, sorry. You're completely right. Of course it's minus, yes. Sorry. It's minus, or A minus, the difference is X and the difference is Y. Still, oh no, there it works. But it's not very sensitive. You see? It does work, but 10 is maybe too small. So let's say 50. 50 maybe is too much. Yeah. So 20. Actually, what one do, this is just for testing, right? What one could do is to say if the distance is less than the width or the height, half height of the alien and half height of the bullet. And this distance has to be, if it's smaller than this distance, means that they're touching each other. And then it will be killed. Okay, let's do it because it's not very optimal. Let's do it as I did it before. So left, if distance is less than the half width of the alien. So alien width divided by 2. So this means if the alien is centered, yeah, this works better, I think. The other thing that you have to check is that the monster, if the monster touches the spaceship, then you're dead, right? So then game is over. So for every alien, I will add it here. For every alien, when I'm checking every alien, if the distance between the alien and the spaceship is less exactly than the alien width, so exactly the same, then print game over and terminate the game. And for that, we call the same function that I'm calling here. If you see the on key press method, it's here I didn't touch what happens with the keyboard, huh? But this, what it's doing is that if, when you press a key, if this key is escape, then it closes the window. This is what it's doing. So I will just copy the command that closes the window, and I will also do it here. So this is, dispatch event means that the program sends the signal close to the system, and then the window is closed. This is exactly the same command that is on key press. Because if you escape the window, then it also closes. Here I just say print game over, so it will print game over on the terminal, and it will close the window. So if you run it, oops, sorry, it's self-spaceship. Because the spaceship is saved as an object in the game. So self-spaceship. So if I let myself die like this, okay. And to finish, the last thing was to create a score, like a text that writes how many monsters have you killed. And for this, we can use the same text that we have for the frames per second. This text. So in the init function, this command ft loads the font. Here you can change the font if you want another font. So this is not that important, but you need to do it because when you call font text, you need the font and the position on the x and y axis. Here x is 0, so that's why you're at the bottom. So here we can create another text that I will call score, and I call it similarly font text ft, and now the position will be x equals the width of the window, and y will be the height of the window. And this will not work like this, but let's do it like this to begin with. So this is, I'm creating a score object that contains, it's with this font, which is double one, and it's at x position and y position. And then when I draw here, I need to do something similar. So self score, I need to draw a text in this text, and then I need to draw it. So let's say here I would say number of kills, and this will have to be a number, right? So if you do it like this without nothing, it's here, it's in the upper right corner, oops, but it's not shown because always the anchor of the text is always in the lower left corner. So when you pass, here, when you pass the position x and y of the score, this is doing it here, and it will write the text like this, so it's outside the window. So what you can do actually is that when you create the text object, you say that the anchor is not here, but the anchor is here. The anchor is the position that determines the position on the object, or determines the position. And for this, I did it. Wait. For this text, here, if you see the documentation, then it says here, H-align and V-align. So horizontal alignment and vertical alignment. And this, you can say that the vertical alignment is top. So you say, so you pass here V-align is top, and top is a constant. So it's Pyglet font top, I think it is. No. Let me check it. Font text top, okay. Font text top. And the horizontal alignment is Pyglet font text right. Does it work? Yes. So this was not working because the alignment of this text was on the other, was in the default, which is left and up, and down, sorry, left and down. So if you go to the documentation and then you check that this text object has this V-align and H-align, which is by default left and baseline. So it was aligning the text to this point. And now what I did was to change it so to the top and to the right. And you see, for that I had to go to the documentation. And it is useful to know, for example, that the different constants. And you can also pass a string. Sorry. You see, you can also pass a string. So you can also do it like this. Yeah. You can also do it like this. And now we need to put actually the score. And for that we need to keep track of the number of killed monsters. And so for that, what we could do is that we could do it in the spaceship. So at the beginning, the spaceship has 0 killed, so has an attribute that is 0, that is killed, kills, let's say kills. And this is equal to 0. And every time we kill one here, in the collision, we do self spaceship kills plus 1. And when we draw spaceship kills. So when in the text number of kills, we add a number that is variable, and this comes from the attribute kills from the spaceship object. You see? So again, I defined in the spaceship, I defined just one attribute that is called kills. That when it starts at 0, and I increase every time here. Every time that an alien is dead, I increase the kills by 1. And this is the value that I show here in the score. And then I draw. Yeah? So it will, now it's 0, but now if I kill one, it will be 1, 2, 3, 4. just for doing that, I did this, the class Spaceship, I created a new attribute. It's called kills. And this, when it's initialized in Spaceship, it's 0. So this will be my counter. This will be inside of the Spaceship. And so every time I update and I detect a collision, so here, this part, every time an alien is dead, then I also increase this counter by 1. So this will keep track of the number of kills. And in the place where when I draw the text, then I draw the text number of kills equals, and then here I put a variable, and this is the number of kills. So with this we recreated the example that you have. In the repository, the files, you have game 1, game 2, game 3, game 4. This is at different steps of this writing. So if you see the slides, in some slides it says after step 2, this point is game 4. So you can check if your writing is more or less what is expected. Do you have any questions? No? Do you like it?
Yeah.
This is now you can, now with these tools, you can now create different versions of the game, right? For example, let's say you want to create a different difficulty, so that the difficulty goes up. You could maybe think that the rate, so the rate at which they create aliens method is called, now it's half a second, but maybe if you do it faster, then it will be more difficult, right? You can change the speed of the bullets maybe, and make it slower or faster. You can make that the monsters, the aliens, go like this, or maybe go randomly. I don't know. You can start to create stuff at this point, right? And then you can just implement them and see what happens. And also the idea was that you learn this concept of object programming. You know that you have to, if you want to add a new attribute, then you have to add it here, and then add it there, and use it up there, and check that everything. This is